Okay, now from section B, we attempt any 4 question of that section. Okay, any 4 of section B. Okay, so first question number 4. The diagram below shows a fish in a tank and its image in seen in the surface water. So यहाँ पे so here we see that a fish and here the object and that is the image in surface of water. Name the phenomena responsible for formation of this image. Easy. That the image is that total internal reflection. Say that if that line this object for water here, there is a water, that is a air. I know that water is more denser than air, so light goes from denser medium to rarer medium. At some angle, we see that some theta and reflected ray with parallel with that line of incident. Okay, like this. And if more that angle, we get that the total internal reflection. So here the answer is that the phenomena is responsible for this is called total internal reflection. That's the answer is total internal reflection. Okay. Next. And the question number B. A double convex lens with a refractive index mu1 inside the two liquids or refractive index of mu2 and mu3. There's a liquid and here's a convex lens. So there's a mu3 and mu2, and here the mu1 is the inside of two liquids. Liquid 1 is refractive index is liquid 1 double convex lens with a refractive index mu1. That is a mu1, that is mu3, that is liquid also mu1, that is a mu2 liquid. In such refractive index, mu2 is greater than mu1. Mu2 is greater than mu1. So here we know that if more refractive index means more density. So as a note, more Ri means more density. Okay, so more Ri means more density. Okay, so means first condition number 1 says mu2 is greater than mu1, means there is a denser, that is a rarer. And okay, a parallel beam of incident of light beam of light refract when it is come out of lens of each cases. So here first figure, consider the figure 1. Here we see that mu1 is greater than mu3. So means denser and that is a rarer. Okay. So in the first figure 1, from figure 1, this is a convex lens, they parallel. Okay. And now light goes from denser to rarer. So first we draw that line of incidence, that is a line of incidence, there these two, and draw a normal, that is a normal here, that is a normal, and we know that light goes from denser to rarer, and the refracted ray means away from normal. So refracted ray goes to away from normal. So away from normal means like this. Away from normal. In light goes this, but light goes in that direction, but away from normal. Okay. So here we see that they are converge at a point. Finally means they are converge at a point. So in figure A, you see that converge at a point. at any point, conversely. In figure B, so number 2, in figure B, light goes from rarer to denser. Okay. If I draw the line of incidence, the tangent represent line of incidence, tangent drawing is not very good, but now draw a normal here and normal here. I know that in light goes to rarer to denser, bend towards normal. If the light goes straight path but bend towards the original path but bend towards normal, sorry, bend towards normal means here the normal, that is the normal, it is a normal. Normal means 90 degree, perpendicular, that is a normal. Towards normal, yes, like this. Towards normal, that is a normal. That goes towards. So case B give divergence or diverge. Okay, clear. Now in number 2, an effective index of water 1.33 at a certain temperature. When temperature of water increases 40 degrees centigrade, the effective index changes to X. Okay. So no, here we see that the refractive index Ri is inversely proportional to temperature. Proportional to temperature. Refractive index of water at a certain temperature, at any temperature, when the temperature of water is increased by 40 degree. If temperature increase and if the Ri and temperature are inversely proportional, so then we know that the Ri also decreases. So at refractive index changes to X, So means X is less than 1.33. So means temperature increases. Temperature increases means refractive index also decreases. So new refractive index is X and old refractive index is 1.33 and new is obviously the less. So that's the true. Here we get X is less than 1.33. So that is the true. Okay, and number B, state 2 difference of normal reflection and total internal reflection. That's very easy question. So normal reflection and total internal reflection. In case of normal reflection, any medium light goes to any medium either rarer to denser, denser to rarer, doesn't depend on medium. But total internal reflection, light uh, goes to denser, goes goes denser to rarer. Okay. And number 2, normal reflection. This there is a diffraction present. Some some part of incident ray goes to refracted ray. Means loss, but number 2, no loss. No loss means no refraction. That's two difference. Number 3, mixture of red, blue and green is passes through a convex lens as they show the diagram below. State whether the ray passes through the single point or different point or principal axis after refraction. Red, blue and green. We know that that is the from Vibgyor. So okay, so that's easy. If deviation decreases from left to right, because deviation decreases And so the longest wavelength means also the longest wavelength, there is important notes here, and lowest energy from left to right, also the lowest energy. So here we see that from these lens is called the convex lens. From know that convex lens passes through a single point and some different single point or through a different point principal axis after the refraction. Now, okay. So in case of this red, so here there comes the red. Here the red and that is the blue and green. So means red is deviation decreases, less deviation, and blue and green are the most deviation, more deviation. So blue or green are the more deviation than, sorry, blue or green is more deviation. Blue and green. Blue and green is a more deviation than red. Okay. Now, next question. Name the invisible radiation which is studied in using the quartz prism. A great question. The basic answer is UV radiation. State one use of this radiation. Surgical instrument. Yet surgical. Yet question. Instrument. Also is producing vitamin D, producing vitamin D. Name the radiation having the wavelength longer than the wavelength of this radiation. Okay, so visible this deviation means visible IR, visible infrared radiation, microwave or radio wave, microwave or radio wave. That is a direct question. Okay, that is a more wavelength longer than the more wavelength of this radius. Number 5. Okay, the object placed at a distance of 24 centimeter in front of convex lens and focal length is 8 centimeter. A direct numerical. Then object placed at a distance 24 centimeter in front of convex lens of a focal length 8 centimeter. So object distance we know that U is 24 centimeter. But in case of convex lens, we always know that is U in minus. And the focal length F, that 8 centimeter. We know the formula 1 by F equal to 1 by V minus 1 by U. So 1 by 8 equal to 1 by V doesn't know, and what is the 1 by U? U is minus 24. So finally we get that is here comes the 1 by 8 minus 1 by 24 minus minus plus here from minus 1 by V, and we get 24 3 minus 1 2 by 24, and we get V equal to 12 at 12 at V equal to 12 centimeter. For now the convex lens, if you draw the diagram, that's the principal axis. Here the suppose that is a convex lens, that is the principal axis, that is a pole first focus, that is second focus, also called the radius of curvature. If focal length that is 8, that is the radius of curvature is 16, and there is the object that is 24. and that is A, that is here 2F. If light goes from like here to their state path, I know the image from first the ray passes the focus. Second, if it goes the try sorry so that goes if goes the principal axis means no deviation goes from state, and that is F into F. That is 2F, that is here. So what is the nature of image is from? The nature of image is inverted. First, that is top A and B, that is B dash, and here is the A dash. The nature is inverted. Okay, image is from first is inverted, and so the size small size with respect to object, with respect to object. Okay, now next. Calculate distance of the image from the lens. That is 12 centimeter. That is the answer. Okay. Or another important, there's a real images. Okay. That image also the so missing has a real image. Okay. Now next. When sunlight passes through a water droplet in the atmosphere, gets distorted into the constituent color, forming a rainbow. A similar phenomenon is observed when a white light passes through the prism. Very easy. And prism. So here the option question number one. Which color will show the maximum angle of deviation and which color show the minimum angle of deviation? Okay. So we know the previous concept. Maximum deviation. If you show the VIBGYO, maximum deviation. So here we know that previous diagram. So means that deviation decreases. So maximum angle of deviation, and that which color show the maximum deviation? The violet show the maximum deviation. Where show the minimum angle of deviation means red. So here the maximum is violet. That is the minimum is red. Okay. Now number, instead of sunlight, green color rays passes through the glass prism. What will be the color of emergent ray? Very easy. If glass prism, sorry, not that prism, is look like this. Prism is look like this. Prism, prism show the dispersion, but if that color is green, out from prism also the color is green. Okay, because white color fall on prism, you get a 7 VIBGYO or violet, indigo, blue, green, yellow, orange, red. But in terms of if we fall on a prism in green color, so out from a disper or emergent ray also the green color. Okay, that's not a VIBGYO. If white light for incident on a prism, the emergent ray are divided into 7 color. But here the emergent ray also the green. Number 3. Okay. On is an luminescent particle trapped inside a glass block. A student traces a path of ray coming out of it and reflecting over a plane mirror. Show the diagram below. That ray here. Okay. Okay. About this. Okay. Now, question number A. Angle of reflection on the plane mirror A effect. Reflection also A, very good. A partially reflected ray in the glass slab. Partially reflected ray. So partially reflected on the glass slab. Here the U, incident and reflected. So that is U. Next, critical angle. That is a C is the critical angle, because a reflected ray uh, line of parallel to line of incident or overlapping to line of incident. That is a C. And refracted ray, Q is a refracted ray. Also the say that T also the refracted ray, but T also say that refracted ray also say that T also called refracted ray. And an angle of refraction of by the of the R of the ray R, angle of refraction Q. Mm, Angle of refraction means 90 degree minus that's not, that's the angle of refraction, that is the angle, that is the Q, 90 degree minus E, degree minus E, because that's the angle of reflection, and we know that that is 90 degree, that is 90 degree minus E, that you get is this. Okay, next question number 6. Okay, a metal rod AB of length 80 centimeters balanced at 45 centimeters from a end A with a 100 GF weight suspended from two ends. If the rod is cut at center C, then compare the weight of AC to the weight of the BC. First, we see that the fulcrum is 45. Okay, so we know that the AC is must be less than BC obviously, because the fulcrum point is here. AC, okay, must be less than BC. Why? Because B has less torque than A. So B has less torque than A, because torque means force times perpendicular distance. That is distance is very small compared to this. Sorry. Okay. Compared to like this, there is a fulcrum point. And C is the center of gravity. C is the center. But here is the fulcrum, that is a 45. So B has less torque because 80 minus 40 means 35. Here comes 45. 35. So here comes 45. So obviously A has more torque. Tau A is greater than tau B. So that's why the side B. So that's why center of gravity also lies in 40 middle of the point. And also beyond the 45. So the more weight concentrated at balance C between C and B. If more weight, so that's why in case of balance we need more weight here. So means if you want to balance this, so need a more weight here. But distance must be same, but needed more weight. So more weight in B to C or C to B. Okay, B and C. Okay. Next, give reason of your answer. Well, that's the reason. Next, each of the following scenarios state whether the work done by the gravity is positive, negative, or zero. Okay, the scenario is number one. Scenario said person walk on a level road. If person walk on a level road, so the weight of the weight is downward. Weight also a force, that is a displacement. Angle between these two is 90 degrees, so that so weight also called Fg, force due to gravity. So work done equal to Fg dot d cos 90. We know that cos 90 is 0, so that is 0. So means 0 work done, 0 work done. Person B climbs a ladder. Okay, here comes the ladder. Ladder means if weight goes down, person moves top. So angle is 180 degree. Okay. So in case of angle is 180 degree. So now to draw a cos 180. So cos 180 means look like this. Cos 0 degree 1, cos 90 degree 0, and cos 180 degree -1. So we get a minus, means negative work done. Car neutral gear is coming down on the slope. If diagram see, car weight in downward, force due to gravity, and displace also the downward. So angle is 0 degree. So cos 0 1, that is positive work done. Okay. Now very easy. And the figure below shows a simple pendulum of mass 200 gram is displaced from the mean position A to the extreme position of B. The potential energy at a point A is 0. At the position of B, at the position B, the pendulum bob is raised by 5 meters. What is the potential energy of pendulum at position B? Okay, that is the potential energy. The potential energy, we know the formula is mgh. So here's the m, the bob mass is 200 gram. 200 gram converted to kg. Now consider g as 10, given 10, and h is 5. So 2 0 3 0 1 2 3 at 10 energy. Na? SI unit is sorry. That is a joule energy. That is 10 joule. Total mechanical energy at point C. Here, the kinetic energy also equal to potential energy. The total energy also, that is the same. The energy conservation law. Also 10 G. To mechanical energy means potential energy plus kinetic energy. 10 joule. Now, when bob is speed of bob at a position A, here that means potential is 0, kinetic energy is maximum. So, you know the kinetic energy formula is half mv square, half m v square 200 by 1000 in SI, v square, that is also 10 joule. Here 20 20 20 20 2 cancel. So v square equal to 100 joule. So v equal to 10 joule. Sorry, not v 10 joule. Sorry. V is the 10 meter per second. Velocity of the bob is 10 meter per second. Okay, very easy. Now, okay. So in question number 7 from doing in next class. Okay. If you any doubt, put in comment section. Okay, so we meet in next class. Thank you.